Hi guys, welcome to the video on oxidation-reduction reactions. This is the first video in our redox unit, and this video is going to be based mostly out of section 4.4 in your book. So we're actually going back into chapter 4, so make sure that you really read section 4.4 because that gives you an even better overview of oxidation-reduction reactions. And then it's also 20.1 in your book. Now, this is a very good website to help. This is at the top of your notes, so if you still need help with redox after watching these videos or after reading the book, then go ahead and go to this website. So, redox reactions, you're going to hear, instead of saying oxidation reduction, you're going to hear me say redox a lot. That's just the shortened way. So redox reactions are very critical in understanding how processes in the world work. They're the basis for energy and different technologies like batteries and fuel cells. One of the most familiar examples of redox is corrosion of a metal. Okay, whenever a metal corrodes or when a metal rusts, that is a redox reaction. Another common example is how the Statue of Liberty is green, right? Because this is actually due to a redox reaction with the copper in the statue. So with these oxidation reduction or redox reactions, these are just a process where electrons are transferred from one substance to another. So it's all about the transfer of electrons. You have one substance being oxidized while another is reduced. Now, oxidation, or something is oxidized, that is when it loses one or more electrons. So whether an element, a compound, or an ion loses electrons, that is oxidation. It will have an increase in oxidation number. So its oxidation number will go up, maybe from 0 to +2 or +2 to +4. And then reduction is when you gain electrons. So when an element, a compound, or an ion gains electrons, its oxidation number is going to decrease. It's going to become more negative because electrons are negative. Now, with oxidation and reduction, one cannot occur without the other. They're a pair, just like an acid and a base. Oxidation and reduction is a pair, and so they always have to occur together. So here's just a visual for you. So the substance that is being oxidized loses the electron, and this electron needs somewhere to go, and so the substance that is reduced actually gains the electron. The reason that it says reduced is because its oxidation number is being reduced. Now, here are some ways that you can remember oxidation and reduction. You can remember oil rig, right? Oil, oxidation is loss, reduction is gain. This is always thinking about the electrons, right? Oil rig, oxidation is loss, reduction is gain. Or you can remember Leo the lion says grr, thus the cowardly lion from The Wizard of Oz. So Leo the lion, loss of electrons is oxidation, grr, gain of electrons is reduction. So both of these mnemonic devices are talking about electrons. It's just whichever one you want to remember. Some people remember oil rig, some remember the Leo the lion says grr. It's up to you. It's a good way for you to remember the process of redox. So some examples of redox. Okay, here we have calcium plus oxygen gas makes calcium oxide. Remember oxidation numbers, if it is in its elemental form, like calcium solid and oxygen gas, these oxidation numbers are 0. But when they go into a compound, they're no longer 0. Oxygen is -2, calcium is +2. From that, then we can look at oxidation number. Calcium's oxidation number increases. It's being oxidized. Oxygen's oxidation number is going down. It's being reduced. It's gaining electrons. And then you can see two other examples. You have zinc and hydrochloric acid, and you have magnesium ribbon and hydrochloric acid, and you can look at the oxidation numbers. So how can we tell if a redox reaction is taking place, right? How can we look at something and say, a redox reaction is taking place, or no, there's no redox reaction here? Well, the first thing you want to do is assign oxidation numbers to each element in the substances. So assign everything, both reactants and products, assign them all oxidation numbers. And then compare the oxidation numbers before and after to determine if it has gained or lost electrons. Because if it has gained or lost electrons, then it's redox. If the oxidation numbers stay the exact same, then it's not redox. So you have this check in your notes. What is the oxidation number of each oxygen atom in the compound MnO2? What's the oxidation number of the manganese atom? So I want you to try this check We'll go over this in class, or you can watch the examples video and we'll go over this in detail in the examples video. So once oxidation numbers have been assigned, I said to compare them before and after. So here's an example. We have iron solid, oxygen gas making iron 3 oxide. So look at the iron solid and the oxygen gas. They both have oxidation numbers of 0 because they're in their elemental form. O2 is diatomic. It's always O2. It's always O2 gas. So these are both 0. But notice when they are in the compound, they're no longer 0. Oxygen is -2. Iron is +3. Notice that iron is going from 0 to +3. Its oxidation number is increasing, and it is losing electrons because electrons are negative. So if it loses an electron, it becomes positive. So 0 to +3. Iron is being oxidized. Oxygen is going from 0 to -2. It's becoming more negative, so it's gaining electrons. Its oxidation number is being reduced, so oxygen is reduced. Notice that a total of 12 electrons were lost and 12 electrons were gained. You have to have somewhere for those electrons to go. Here's another example looking at iron 3 oxide plus carbon solid makes iron solid and carbon dioxide. So again, you always want to start by assigning oxidation numbers. +3 -2, 0, 0, +4 -2. That's just first looking at the ones that are 0. Solid carbon, solid iron are 0 because they're in their elemental forms. You can actually look at the iron 3 oxide just by doing the reverse crisscross. So this 3 is going to go up to the top, this 2 is going to go up to the top. But then with CO2, always start with oxygen. Okay, this is not a peroxide, so oxygen is going to be -2. But because this is -2, carbon has to be +4. Remember, they have to equal 0 because all of these compounds are neutral. If all the compounds are neutral, the oxidation numbers have to add up to equal 0. So iron is going from +3 to 0. Its oxidation number is being reduced, so iron is reduced. Carbon is oxidized, and oxygen undergoes no change. Now, not every single atom has to undergo oxidation or reduction. You just always have to have one thing being oxidized and one thing being reduced. Again, 12 electrons were lost and 12 electrons were gained. And notice in both of these examples, oxidation and reduction always occur together. So as we're looking at oxidation and reduction, we're going to start talking about a reducing agent and an oxidizing agent. So we're going to start with the reducing agent. It also might be called the reductant, but typically you're going to see it called the reducing agent. The reducing agent is something that causes reduction. Right? It is an agent for reducing. So it causes reduction. So it loses electrons and it undergoes oxidation. So the one that is the reducing agent is what allows the other thing to be reduced. So that means that the reducing agent actually undergoes oxidation. It's the one that loses the electrons. And then the oxidation number of the reducing agent will increase because it is undergoing oxidation. So this is kind of just a twist in your mind shift because you always want to say like, oh, the reducing agent must be the one that's being reduced, but that's not the case at all. The reducing agent is the one that is actually undergoing oxidation. It's allowing something else to be reduced. And then the oxidizing agent, or the oxidant, causes oxidation. It gains electrons. It itself undergoes reduction. And so therefore the oxidation number of the atom decreases. Now this is the list of reduction reactions. Okay, so these are oxidizing agents. These are things that undergo reduction. You need to memorize these. So the ones that say know these for sure, these are the ones that you need to know for sure. Right? And it tells you the reactant and it tells you the product. So elemental halogen like Cl2 will form Cl-. The metal ion that's in the higher charge will form the metal ion of the lower charge. So like iron 3 will be reduced to iron 2. So you want to know these for sure. So make flashcards, however you memorize. And then the bottom half, these are less common, but they're definitely fair game, especially this top one, MnO4- in basic solution. That's one that it's becoming more common. And then these are the reducing agents. These are what undergo oxidation. So halogen ions become the element, metal ion in the lower charge becomes that of the higher charge. So notice that they're just kind of backwards. So you want to know these top 3 for sure, and then the bottom 4 are less common, but they are fair game. So these are ones that you do want to memorize. Just that way you've got them off the top of your head. and you don't have to really think through it. So recognizing oxidation and reduction reactions. Here's a table that just summarizes oxidation and reduction reactions. So in terms of oxidation number, oxidation reactions increase in the number, reduction decreases in the number. In terms of electrons, that's where you want to remember oil rig or Leo the lion says grr. Okay. Oxidation is when you lose electrons, reduction is when you gain electrons. And then in terms of oxygen, this is actually where the term oxidation comes from, because oxidation is when you actually gain oxygen atoms, reduction is when you lose oxygen atoms. So this is just a table that summarizes these oxidation-reduction reactions for you. So in general, metal and anions act as reducing agents. They're the ones that are oxidized. Nonmetals and cations are typically the ones that are reduced, so they act as oxidizing agents. And then remember, metals on the left of the table are more active and they become less active as you move to the right side. So this deals with the activity series. So what that means is the metals that are much more active are going to be the ones that are much stronger reducing agents versus the less active metals, which just they will not be as common with reducing other atoms.